up again because polynomial division, probably long division, probably once is enough fun, okay? All right, yes. I have the learning targets sheet if you want a copy, okay? Can I just leave it at that and you can see? All right. So worksheet 5 talks about the remainder and factor theorems, which start out with the idea of long division and division. If you weren't here Friday, or honestly, I can't remember if I even told this class on Friday, but if you are in Skyward and you have summative scores from the 23rd to the 31st or the 13th of November, okay, you need to get those retaken this week if anybody still wants to retake anything. Any questions about that? In the grade book, it would be summatives, don't look at formatives, but summative scores from the 23rd to the 31st or the first quiz in September. So anything older than September 13th that's a summative that you still want to retake, you need to let me know this week, okay? Most of you are all up to date, so it's good. All right, we went over, this is from Friday. I didn't know that we needed to necessarily go through it again. Remember the concept? Dividing, long division. Anybody who wasn't here Friday? So it's, you think about the multiplication. You know, you say to yourself, how many times does it go into this? But what you're really thinking is, what am I going to multiply to get close to this? Okay, so when we do it with polynomials, we're going to multiply to get exactly a number. Of course, I don't have this thing going yet. And then we also talked about writing answers as fractions. When we do this question and we get 48 remainder 5, this is algebraically how we're writing that. Everybody okay? I don't remember who was here Friday and who was gone. All right, so you can divide polynomials using either long division or synthetic division. The process of dividing by long division is similar to arithmetic, where you divide, multiply, subtract, okay? The big thing is it has to be written in standard form with placeholders for missing terms. In other words, if I was dividing something into this, I would want to write a 0x squared in here. Everybody understand what I'm talking about by placeholders? Okay, synthetic division is a shortcut, and it only works when the divisor, what you're dividing by, is x plus or minus some constant term. All right, so you can just watch this one. It's already done for you on your notes. First of all, this did not have an x squared term, so we put a placeholder in. When I divide, what I do is I say x times what will become exactly 3x cubed, okay? If you weren't here Friday, please be paying close attention. X times what becomes exactly 3x cubed? 3x squared, okay? So now I'm going to multiply this 3x squared times this x and get 3x cubed. I'm going to multiply this 3x squared times the 1, so I'm basically distributing, and I get plus 3x squared. The next step is to subtract. When I subtract, I always write this. I'm subtracting this quantity, and then I change it to adding the opposite. However, you're going to do it so you remember you're subtracting both. So this is 0, but this is a negative 3x squared, and then I bring down. So x times what will give me exactly negative 3x squared? Okay, so negative 3x times x is negative 3x squared, but the negative 3x also multiplies by the 1, so I get negative 3x. I need it to be exactly the same because then when I subtract, okay, it becomes minus a negative or plus positive. The same thing happens back here, or I just change the signs and add. I have 1x minus 4 1x goes into x once, yes, so I need to multiply by exactly 1. I get 1x plus 1. Again, I'm subtracting. So if I add and change the signs, I get what? Be careful. No. -4, I changed it to add a -1, or it was subtract +1. It becomes -5. So the remainder is -5. Or we write 3x squared minus 3x plus 1 plus, there was a -5 and it goes over the divisor of x plus 1. All right, synthetic division for the same question. The 0 for this, if I set that equal to 0, I will get -1. Then across the top go the coefficients. 3, there is a 0x squared, so I have to put a 0 placeholder. This is not just a convenience. You have to do it with synthetic division or you'll get the wrong answer. Okay, and then -2 and -4. You're just putting the coefficients. Then the rule is drop the first one down, multiply, add. -1 times -3 is multiplied to become 3. Add, -2 plus 3 is 1. Multiply, -1 times 1 is -1. Add is -5. This is called the depressed polynomial. This is the remainder. Yes, and you start at the back, and this term is the constant term. This term is the linear term, so it gets an x. This is the quadratic term. And you would keep going however many terms there are, but you always start from the back. So we wind up with 3x squared minus 3x plus 1 with a remainder of -5, which could be written as -5 over x plus 1. And this is added, or you could just write it as a minus since it's -5. Questions so far? All right, so let's practice. It says to do this one by long division. Guys, everybody ready to try this on your paper? We need any placeholders on this one? Okay. Anybody want to talk me through it? 2x needs to become exactly 2x cubed. So what do I need to multiply by? X squared. Okay, x squared times 2x is 2x cubed. I'm distributing it over here to both of these terms out here. So I have to do x squared times -1, which will be a -1x squared. Then I'm subtracting all of this, or adding the opposite. So what do I get back here? 4x squared. Everybody okay? Bring down the -8x. And you might need to bring down more. You just have to wait and see. All right. Now 2x needs to multiply again by something to become exactly 4x squared. So we need another 2x. So then we multiply 2x times 2x is 4x squared. 2x times this -1 back here is -2x. You don't know what's going to happen back here. It may drop out, it may not, okay? You only focus on the first term. Then we are subtracting or adding the opposite. So the x squared should drop out. I have -6x plus 3. What do I need to multiply 2x by one more time to make it exactly -6x? Okay. And I get -6x plus 3, right? -3 times -1, which is exactly what we had. So if I subtract or add the opposite, I get a remainder of 0. Okay. One more time. The purpose for this, I talked about this Friday, I think, but when we have a polynomial or a rational function later, which is section 2.5, we have something like this. And we're supposed to graph it. The end behavior will approach this, and you have to be able to find that end behavior equation. Basically, this is going to have an asymptote at 1/2, but it's going to do something crazy like this, so that it's got something weird going on here, but outside of here, it actually looks like a parabola, which is this, okay? Yeah, that's a lot of scribbles, because I'm just making stuff up, so I don't want you to think it's going to be accurate. But all right, did you already try this one? I know some of you are working ahead. 2x cubed plus 5x squared minus 7x plus 6 divided by x squared plus 3x minus 4. Anybody? What do you got? Or just tell me what to do for the first step here. Good job. So then we're distributing it to all three of those things. 2x, go ahead, get 2x cubed. It was minus 8x at first, but then if you're me, you distribute the negative through because I get confused otherwise. All right, so what did you come up with after that? That is what I have. I have 2 as the remainder. You are right. 4x plus 2, right? Did anybody else have 4x plus 2? Okay. Sorry. So the answer is 2x minus 1 plus 4x plus 2 over x squared plus 3x minus 4. If it says to write any remainder as a fraction, that's what it would be asking you to do. The check, guys, no one wants to do the check on one like this, but you would take the answer we got times the divisor, adding on the remainder, and it would get back to the dividend here. So we'd have to FOIL all this out and then add this remainder, and it should get back to 2x cubed plus 5x squared minus 7x plus 6. All right. Do we need extra practice, or are we okay? All right, so synthetic division. Remember, you have to use zeros as placeholders, and it only works when you're dividing by a linear term with a coefficient of on the x of 1. All right, so who wants to talk me through this one? What goes in the box? This is where everybody gets messed up. Yeah, it's -4. And my leading coefficient, or my coefficients here for this one, guys? Okay, good call. All right, so we do bring down, multiply, add, multiply, add, multiply, add. Anybody else get that when they tried this one? So what happened? It went in evenly and it came out what? Okay, because this is the remainder. This is the constant term. This one gets an x. This one gets an x squared. Okay, can you try 4 on your own then? 2 placeholders this time. Is that right, guys? I usually make a multiplication or addition mistake. Usually something really easy, like a 0 or something. Did everybody get a remainder of 10? Okay. So the depressed polynomial would be an x squared, and an x cubed. Yes? X cubed plus x squared minus 2x minus 2 plus 10 over x minus 1 if it said to write the remainder as a fraction. Everybody good? Anybody sign mistake? Got a question? All right, good job. All right, so the remainder theorem, which was in the name of the lesson here, says the remainder theorem states that if a polynomial is divided by a factor, the remainder you get is the same as if you put that 0 into function. All right, this allows you to evaluate by dividing using synthetic division, and it's called synthetic substitution. What's it talking about? Well, if you want to know the number of tickets sold during the Northside football game can be modeled by this crazy equation where x is the number of games. Use the remainder theorem to find the number of tickets sold during the 12th game. Well, if we have a calculator handy, we could just type a 12 into all of these x's and be done with it, right? That would evaluate the function at 12. But if we didn't have a calculator handy, it might be easier to do this synthetic division because the answer will be this term. Do you see that the numbers, I don't want to have to cube these things in my head, right? But if I bring down the 1, multiply, add, multiply, which is 0, add 48. I do have to do 12 times 48 and add 74, but I got 650. That was more timely than trying to do all this long math in my head, cube 12, blah, 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 blah. Okay, that's all it is. Okay, it just, what it means though, is if we want to find out if something, we can work it either way. If we want to predict whether something is going to be a factor and come out even, we could just put the number in and see if we get out 0. Put the number into the function, see if we get out a 0. All right. If you use remainder theorem to evaluate a function at a value and it comes out 0, then you know that x minus that is a factor, which is the factor theorem. It says if you want to know if this is a factor, it works if and only if when you put the value in you get out a 0. All right, so a little quick practice here to determine whether this is a factor of this. We're going to first substitute a 2 in. So anybody with their calculator warmed up want to do this real fast? This would be 8 times 2 is 16, 4 times 5 is 20. I think it's 0, isn't it? Okay. So is this x minus 2 going to be a factor or not? It should be. Should come out evenly. So how could we check our answer? To question number 4 on the front, is that what it's asking about? Okay, so how could we check that we divided this correctly? Okay, find f of 1 for this function. So we'd have 1 to the 4th minus 3 times 1 squared plus 12, which would be 1 minus 3 plus 12, which is 10. Did that work? Is that what we got as a remainder? Okay. So let me, just for clarity, actually, I think what I want to do is, nope, just kidding. That wasn't what I wanted to do. Can I just, no, nothing? Okay. All right, I want to take this for the notes for people who are needing the notes. Put it here. So we did get 10 when we checked this. All right. So it says use the factor theorem to determine if the binomials given are factors of this. Okay, so they give us this huge long, and they're going to do this on the homework. They have this huge long thing, and they want to know, is 1 a factor, is 3 a factor, etc., as x minus 1 or x plus 3. So they suggest you use synthetic division. This comes out 48. This comes out 0. So which is a factor? X plus 3 is a factor. And the depressed polynomial tells us what's left after we take out that factor. Does that make sense? Okay. This one was not a factor because it did not come out even. I would probably have typed it in my calculator by inserting the value into the function because I have a calculator, right? It doesn't require me to write anything down, but it says use to determine if this is a factor. So if we were doing this by synthetic division, how could we determine if this is a factor? Yes, we're checking if the 0 of -5 goes evenly into x cubed minus 2x squared minus 29x plus 30, no placeholders needed, right? Okay, bring this guy down, multiply, add, multiply, add, multiply. I got 0. Did anyone else get 0? Okay. So what is the factored form that we just found? Okay, x squared minus 7x plus 6 times what gave us the original polynomial, though? We just factored out a what? X plus 5. Okay, we want it to equal the original f of x. Now, does this factor further? X minus 6 and x minus 1 gives us a minus 7 and a plus 6. So if we were to graph this, we should have x-intercepts, all of which cross, not bounce, right? And we can predict total end behavior. All right. This is an extra example, but this is a concept. Eventually, you're going to have to factor something completely and prove that it factors completely. I want to talk about successive divisions. Okay, can you just look up here for a second? If I want to know that one or both of these factor in, I don't have to go back to the original polynomial. I can use the depressed polynomial. What that means is if I put in -4, 36, am I doing this right, guys? Anybody checking my, I got a 0, so I hope so. Now, I just proved that this is a factor. But if I want to prove that this is a factor and I want to keep factoring, it doesn't matter if I go back to the original one. If I have to find the totally factored answer in the end, it makes more sense to keep going from here. because I know -4 went in evenly, so 5 has to go in evenly to this, then it would have gone in evenly to the first one. So if I bring this down, okay, it's going to ask you to do this on the quiz and on the final. What have we just found are the factors of this polynomial? X plus 4, x minus 5. You're telling me that would get me back to this. Yes, this is the third factor. Now, does this make sense at all? If we multiply all three of those things, we'd be back to this. We found the completely factored form, okay? So this is called successive division, meaning you don't go back and use the original, you keep going. All right, so we're going to try these. If it doesn't work, then we're going to have to go back, but it does say to graph it first to see which ones are going to work, so we want to try them first, but I don't even want to mess with it. Can we just try them and see what happens? Okay, if these are all linear terms, so we can use synthetic division. Okay, if I try 1 first, actually we might try 1 just by plugging it in our head. We'd have 3 plus 8 minus 15 minus 32 plus 12, right? Just plugging in a 1 real quick. That'd be 11, -4. I don't think 1's going to work. Did anybody try it? Definitely not working, right? We had -24. I don't know. Did anybody get that? -20, -35. Should be. I think I got it both ways. All right, so that was helpful. That's a no. All right, so now, can we keep going from this depressed polynomial? No, because that didn't work at all. So now what are we going to try? -2. So we have 3, +8, -15, -32, and 12. I'm hoping this is going to work. So bring down a 3. -2 times 3 is -6. Add and I get 2, multiply. -4, add and I get -19, multiply and I get 38. Yes. Add and I get 6, multiply and I get -12, which adds to 0. So this is yes, it's a factor. And since it's a factor, I can try this in the new depressed polynomial to see if it is also a factor. What would go in the little box this time? +2. Bring down the 3. 2 times 3 is 6. Add and I get 8. 2 times 8 is 16. Add and I get -3. 2 times -3 is -6. Add and I get 0. So this is also a factor. So I know that x plus 2, x minus 2, and what's left here, guys? Okay, does that factor further maybe? I don't know. Let's think about it for a minute. That would be 9. 9 minus 1 would be a +8 in the middle, and it would give us a -3. So if we had graphed this, we were supposed to at the beginning, we should have seen 4 zeros, none of which repeated, yes? Okay. But to arrive at the factored form, when we started with a degree 4, we needed to do at least 2 of them to get down to something we could then factor ourselves. Yes? I don't know how to factor a degree 4 off the top of my head unless it happens to factor by grouping or something. Any questions on that one? All right, so again, this is tying all that vocabulary together. Okay, if it's a factor, then f of c will equal 0. If the remainder is 0, then x minus c is a factor, which means c is an x-intercept, which means x equals c is a solution if the equation is set equal to 0. All right, this is number 59 of the assignment, which is not actually assigned. It says graph, find zeros, divide successively, and factor completely. I want to talk about these though first because it says here we're supposed to do 53 and 59 together. Okay? Before we do this, this is off your assignment sheet. Let's do 53 real quick. It says find the value of k so that this is a remainder is 0. Can I show you how to do this real quick that you don't have to do so much extra work? Do you remember this? If the remainder is 0? So what would we want to plug in here to make this work? Okay, so f of 2 should be 0. So if I put a 2 in for all of those, I'll have 2 cubed minus k times 2 squared plus 2 times 2 minus 4, and it's supposed to equal 0. Could you then solve for k? This is 8 minus 4k plus 4 minus 4 equals 0. Well, those just go away. I'd have negative 4k equals negative 8. If I move the 8 to the other side, I got k is 2. Can do that? Everybody's okay? You can do it by synthetic division, but it's big pain in the neck. All right, we're supposed to do this one. Did anybody happen to type this in yet? Well, we're supposed to completely factor it. So we need to know what some of the zeros are by graphing. While someone's doing that, I'm going to write down the coefficients. I'm thinking either 1 or negative 1 might work. Okay. See if you can find me another one that works while I'm trying this one. Ugh, help! It's not 1? 1 doesn't work? Anybody find one that worked from the graph? 2? Okay, 1 does work. Guys, I need help. What's negative 153 plus 19? 4. Okay. Negative 134 plus 54 would be negative 80. Times 1 would be this. Help. 724 minus 80. I don't think this works. Negative 6? Okay. I'm just going to erase so I don't have to rewrite this. Okay, I need somebody with their home screen available here so that we can, so they can type for me. 6 times negative 6 is negative 36 plus 13 times negative 6 minus 153 times negative 6, 144 times negative 6. which is times -6. Okay. Did anybody find another one? Ew. Nothing else? Oh, lovely. Okay, somebody help me. -2.5 times 6. Oh, this should have been -15. Okay. So -15 and -23 is -38 times -2.5. So then I have 80 times -2.5. -56 times -2.5. Okay. Anything else? What is 2 1/3? 7/3. So somebody help me. 6 times 7/3. It's 14. -38 plus 14 times 7/3 plus 80 times 7/3. No, it should be 56. Oh, there was a nicer number we missed. 2 worked. Okay. Wait a minute. Okay, so what we came up with, guys, so the factors we have so far are x plus 6, x plus 5/2 or 2.5, x minus 7/3, and this. But look, 6x squared minus 24x plus 24. What can we take out of all that? Can take out a 6. Okay. Take out a 6, and we have x squared minus 4x plus 4. How does that factor? Guys, how does this factor? X minus 2 and x minus 2, right? Okay. Now, it bounces there, yes. Now, there is a 6 that was out in front. What could we do with that 6? How could we write the factors differently? This is the completely factored version, or x minus 2 quantity squared, x plus 6. What if we wrote this as 2x plus 5? What did we multiply this by? 2. And we wrote this as 3x minus 7. What did we multiply that by? 3. And that's where the 6 comes from. Okay, so this is the completely factored version without the fractions. This is equivalent, and that's okay. All right, I don't think that there's necessarily one with an 840 that you were assigned. I think I picked a disgusting one, okay? But you do, obviously you're going to have to graph it to start off with. Does everybody understand that? Okay. So these, now, if you did the synthetic and long division questions Friday that I suggested, those were those 4. So you might only have 5 more questions to do tonight. Otherwise, you have these 9 assigned. Any questions? All right.